For the first time in history, NASA has delved into the Sun, capturing astonishing images that defy the imagination. During a study of Sun images, 3 disconcerting structures surfaced on the Sun's exterior. The first revelation unveils a spectacle of the Sun experiencing a literal downpour, with scorching plasma cascading from sky. Moving on to peculiar grass-like formations, these structures astonish with their colossal size, surpassing even the grandeur of Mount Everest. Lastly, the observation of surface cracks birthing bubbles larger than the combined expanse of Rajasthan and Madhya Pradesh adds another layer of intrigue. Welcome to Spaceverse, your cosmic hub for all things space. Join us as we unravel the science and technology behind ISRO's Aditya 1 mission, exploring the Hardcore mission and its groundbreaking discoveries. Subscribe for weekly cosmic insights and let's journey through the cosmos together. This prompts the question: what is occurring with the Sun, and is it within the realms of normally? If so, why are scientists engaging in such studies? The concern deepens considering that NASA's Solar Dynamics Observatory captured these images from a considerable distance, an achievement seemingly impossible from its position. This raises inquiries about the methodology employed by NASA in accomplishing this challenging feat and prompts a reconsideration of our comprehension of the Sun. Faced with numerous intriguing questions, NASA has meticulously decoded the latest Sun images, piecing together a comprehensive understanding of the phenomenon observed. Scientists were already aware of environmental events surrounding the Sun that could pose significant threats to Earth in the future. The repercussions of solar flares caused by these events became evident in 2022 when not only yon Starlink satellites but 149 others succumbed to their influence, plummeting back to Earth. The urgency of studying these phenomena became even more apparent in 2023 when a potent solar flare equivalent to 1 billion hydrogen bombs impacted North America. This event led to widespread communication disruptions and a significant blackout across most of the continent. Historical records indicate that from 1580 to the present, the Sun has unleashed such solar flares on Earth 33 times, resulting in substantial damage to both the planet and its technology. To mitigate potential future impacts, NASA and ASA have embarked on a mission to approach the Sun closely for in-depth study. The goal is to closely monitor and analyze the ongoing activities on the Sun, enabling more accurate predictions of solar events. The joint mission, initiated in 2010, involved launching a spacecraft into the inner orbit. This mission focused on studying various electromagnetic wavelengths emitted by the Sun into the layers in Earth's atmosphere. These observations provide crucial insights into the diverse layers present on the Sun, contributing to a more comprehensive understanding of its dynamics. The S layers, consisting of the outermost corona, the middle chromosphere, and the innermost photosphere, exhibit distinct temperature variations. Given that different temperatures emit different wavelengths of light, scientists utilized multiple wavelengths to study the Sun comprehensively. Their initial focus was on the outermost layer, the corona, which they observed using ultraviolet or UV. In their exploration, scientists were astounded to witness what appeared to be hot boiling lava raining down on the Sun. This phenomenon, upon closer investigation, was identified as a small part of a larger process occurring in the SIN corona. The SIN plasma, a mixture of charged particles, interacts with its robust magnetic field. This magnetic field propels the plasma outward because when charged particles in motion encounter a magnetic field, the field exerts a force and ejects them. This process is responsible for the solar flares that emerge from the Sun. These flares, incredibly energetic, can complete about 100 round trips from Earth to the Sun in just a few hours. However, akin to the water cycle on Earth, these scorching flares cool down as they reach the outer layer of the corona. Subsequently, they descend back to this in surface in the form of lava rain. Scientists have aptly named this captivating phenomenon observed and captured in the corona coronal rain. In summary, the initial images of the SIN's outermost layer revealed solar flares, leading scientists to uncover the intriguing phenomenon of coronal rain. Armed with this understanding, they ventured closer to the Sun to investigate its middle layer, the chromosphere, utilizing UV light of a specific wavelength. Due to the lower temperature of the chromosphere compared to the corona, scientists captured images that revealed a surprising revelation. Contrary to the previous assumption of a relatively plain chromosphere, the images unveiled the formation of structures resembling Mount Everest in height, occurring every 5 minutes. Astonishingly, these structures, akin to grass dips, were rapidly ejected at a speed 60 times that of the SIN's outer layers. This phenomenon arises from the SIN's equator completing a rotation faster than its poles, resulting in a twisted and entangled magnetic field, forming small loops on the in-surface. As these loops in the chromosphere of the Sun become entangled or untangled, shock waves are generated, resulting in the formation of sharp grass-like structures. This phenomenon is akin to putting water on a woofer and observing the water jump like pointed thorns in response to sound vibrations. The images of this layer allowed scientists to unravel the secret behind the grass-like structures forming in the SIN chromosphere. Moving on to the next layer, the photosphere, scientists altered the wavelength of light once again. The photosphere, with its temperature of 5000 C, is visible in the brightest visible wavelength. Through this filter, images of the in-surface or photosphere revealed numerous cracks. The perplexing question arose: why are these cracks forming on this in-surface, and how significant are they? Upon capturing Images in this wavelength. Scientists initially observed unclear images, suspecting that these cracks might be pixels. To investigate further, they zoomed in and discovered that these were in fact the corners of the sun that experienced constant damage. These features were aptly named solar granules. The most intriguing aspect of these granules is their size. Despite appearing as small pixels, they are as large as the biggest US8 Texas. These solar granules on the insurface are formed through a process similar to the one that led to the creation of supercontinents like Pong on Earth, much like the temperature differences beneath Earth's surface causing hot lava to rise near the core and cold lava to descend. The SIN core experiences a similar process. Hot plasma near the SIN core rises while cold plasma descends, creating a pattern that when viewed from above appears as bubbles with cracks between them. The zoomed-in image of the photosphere reveals dark spots that were not immediately apparent in the original zoomed-out view. These spots, distinct from solar granules, are explained by NASA's formations resulting from the SIN's magnetic field, which, as mentioned earlier, twists like a rubber band, creating small loops on the insurface. On a macro scale, the snapping of these loops generates shock waves, but on a microscopic level within the plasma an opposing phenomenon occurs. The strong magnetic field causes the charged particles within these loops to align in a uniform pattern, much like iron filings around a magnet. The vibration of these aligned charged particles decreases, leading to a cooling of the plasma and the formation of dark spots on the SIN surface. The images of the plasma in the SIN layers provide insights into what is known as the gravitational pull of the plasma. Interestingly, there are two aspects referred to as the mass of light. One is the mass of light from the sun and the other is the image of the sun captured from Earth. It's somewhat ironic that we witness this deep image of the sun taken from Earth every day, particularly during sunrise or sunset, when we observe the smooth surface known as the photoosphere. As demonstrated in this video, studying the various layers of the sun allows us to piece together a comprehensive understanding of the intricate processes occurring within our sun. This is why space agencies like NASA and ISRO closely monitor the sun. While the video indicates that nothing extremely unusual is happening with the sun, there are still unanswered questions. For instance, if everything is normal, why have space agencies including ISRO launched 10 solar missions in the last 20 years? This curiosity persists, especially considering the sun is not a planet where the search for water or similar resources is a primary concern. Their repeated research and the launch of multiple solar missions might seem intriguing, and many may wonder if there's a hidden reason or if scientists know something the general public doesn't. Initially, it might be easy to assume that the increasing number of solar flares from the sun is the primary reason for these endeavors. However, a closer look reveals that NASA has sent various satellites before the Solar Dynamics Observatory or STU to study solar phenomena. Satellites like the Solar and Heliospheric Observatory or SOHAL launched in 1995 and the Solar Terrestrial Relations Observatory or STEREO launched in 2006 were sent to study solar activity. Despite their contributions, these spacecraft face challenges such as slow data transfer speeds and lower picture quality. The STU addresses these issues by sending data to Earth in a mere 0.75 seconds compared to SOHAL's 12 minutes and STEREO's 1.5 minutes. Moreover, the STU produces images that are 10 times better in quality than its predecessors, and NASA anticipates it will send 50 times more images than other missions with similar objectives. In the pursuit of a comprehensive understanding of the sun, scientists rely on data from various missions. Each mission contributes unique insights, and the continuous launch of satellites like the Indian Space Research Organizations or ISRO Diggle-1 underscores the importance of gathering diverse and detailed data. DIT-1 is expected to provide valuable information surpassing NASA's Parker Solar Probe, even though both will be suspended at the same point between the Sun and Earth. The collective data from these missions enhances our comprehension of the Sun and its complex dynamics. And that's it. Thanks for joining us on this cosmic adventure at Sparsea. If you enjoyed exploring the mysteries of space with us, don't forget to like, share and subscribe.